Hey there, welcome to Pomodoro Joe for Thursday, November 2nd, 2023. Today we're looking at LeetCode problem 2265. Count nodes equal to average of subtree. This is a medium problem. Given the root of a binary tree, return the number of nodes where the value of the node is equal to the average of the values in its subtree. Note, the average n elements is the sum of the n elements divided by n and rounded down to the nearest integer. Okay, a subtree of root is a tree consisting of root and all of its descendants. Oh, interesting. So they're calling a subtree of root as including the root node itself. So the root node plus its descendants. All right, then we have an example here. 4, 8, 5, 0, 1, and 6. And now it looks like all the blue nodes are the ones that are the average of their descendants. So 0, well, if you add its children, it's 0 and 0. There are no children. Now we are including the root node of this subtree itself. So 0, and we divide it by one element is 0. So it's 0. Yes, then this one, so this is 1. It's divided by one node. So 1 divided by 1 is 1. So yes, its value is the same as the average of this subtree. All right, 8. Well, if we look at the subtree, so that includes the node itself, so that's 8 plus 0 plus 1. So that's going to be 9 divided by 3 nodes. So that's going to give us an average of 3, which is not the same as 8. So this one is not going to be counted. All right, let's go down to 6 because that'll be easier. So 6 is a leaf node. So the subtree here is just this node itself. So that's 6 divided by one node, which is also 6. So that's going to be counted. Now 5, we have 5 plus 6, 11, but it's divided by two nodes. 11 divided by 2 is going to be 5.5. Round it down to 5. So that is indeed 5. So that's going to be counted. And then 4, wow. So now 4 is going to be 4 plus 8 plus 1 plus 5 plus 6. All right, well, let's see. 4 plus 6 is 10, plus 6 is 16, plus 8 is 24. And we divide that by 1, 2, 3, 4, 5, 6 nodes. So 24 divided by 6 is 4. So that's going to be counted. All right, so this is fairly straightforward. It's going to be a little bit tricky to actually do our traversal, but let's just jump in and see what we can do. So let's put 25 minutes on the Pomodoro timer and we will get started. So we'll start with some result, set it equal to 0, and we will return our result at the end. All right, for this one, I think I'm going to break this down into two pieces. We'll have sort of the engine that goes through and traverses the tree, and then we'll have a helper that will actually calculate the averages for us. So just like in yesterday's problem where we were traversing a binary search tree, we'll be using a queue to go through our tree node by node. So let's start with our queue. We're going to make that a list that just contains our root node to start with. All right, now while we have something in our queue, so while we still have nodes to process, let's grab a node out of the queue. So this node will equal queue dot pop, and I'm going to pop at index 0. All right, so we grab this node. So now let's find the average value of this node's subtree. So let's see, we'll call this average. And let's just create a function that's going to do this for us. So let's see. I'm going to call it average of subtree helper. All right, and we're going to pass in this node. So assuming we have this function, let's actually create this out here. So we have this average of subtree helper. It's going to take our node, and for now I'm just going to pass. Let's assume this works. So if this works, then all we have to do is compare our node's value to this average, and if it's the same, then we can increment our result or increase our result by 1. So if this node val is equal to our average, then our result will increase by 1. All right, so we've grabbed a node out of our queue, processed it. Then we need to check if it has child nodes, and if it does, then we need to put those nodes in the queue for processing. So if node.left, we'll put it in the queue. And if node.right, All right, and that's it for our main engine here. So we have our queue. We're going to start it with the root node. We're going to pop a node out, do some processing, and then if there is a left node or a right node, we'll put those nodes into the queue as well. And then we'll keep processing until we run out of nodes to process. Cool. Now let's go back to our average subtree helper here. So now for this one, we need to calculate the average value of this tree, or this subtree. Now, in order to calculate this average value, we kind of need two pieces. We need to know the total value of all the nodes, and we need to know how many nodes there are. So in fact, we need to have both the value and the count, the number of nodes. So in that case, this is actually going to return a tuple. And so the tuple will wrap two values. One will be the total value, and the other will be the count of nodes, or I'll call this node count. All right, so this is going to be a recursive function, so we'll start with our base case. And the base case is there is no node. So if not node, then we can just return 0, 0. There's no value, and there's no count of nodes. All right. Now we can also check if this is a leaf node, if node.left and node.right. So I actually want to say if not node.left and not node.right. So in that case, this is a leaf node. And let's see, we can return. So this is one node, and it's going to be this node's value divided by one node. So that's just node val is the average here, or the total here. And then it's one node, so we can just return 1. All right, now we have a case where we might have a left node, we might have a right node. We're definitely not a leaf node, but let's just get our left value here. So this is going to be a recursive call on the left node. All right, so node.left, and then we'll get the right. Okay, so we're going to recursively call this on our left subtree and our right subtree. And now we have all the pieces we need. So now at this point we can return. All right, so we need a tuple here, and this is going to be the total, and this is going to be the count. Let's get that out here. So our total, well, that's going to equal this node's value plus the return, the total from the left node, so that's left at index 0, plus the total from the right node, so that's going to be right at index 0. And then the count is going to be this node, so that's 1, plus the total from the left, so that's going to be left at index 1, and the total from the right, so that's going to be right index 1. All right, so I think this might be it. Let's give a little bit of room here. All right, so this is our recursive function. We're going to pass in a node, and it's going to calculate the total value of all of its subnodes, including itself, and it will calculate the number of nodes, including itself. So if we don't have a node, it's just going to return 0, 0. We have no total, we have no nodes. Otherwise, if this is a leaf node, it has no left or right nodes, we can just return the node value itself and 1 for one node. Otherwise, we'll recurse on the left and right nodes. We'll just pass in the node's left node and the node's right node. Then when we get these back, we can calculate this new total. That's going to be this node's value plus the left node's total plus the right node's total. And we can calculate the new count, which is this node plus the count from the left and the count from the right. And then we could just return the total and the count. So that does mean we have to adjust this a little bit. Now this was just returning the average, but now we're returning the total and the count. So let's do that here. So this is actually total and count. So now we actually have to calculate the average from the total and count. So average is going to be equal to total, do an integer divide by count. All right, I think we're done. Let's run this and see how we do. All right, seems to work. Let's submit this. And we pass. Let's see, we do not do very well at all. We're only beating about 5% for runtime and 58% for memory. So this is not great. Let's jump back here and see if we can do a couple things to tweak this, maybe make it a little bit faster. Let's see, one thing we could do, we can add caching here. That's simple. Another thing we could do, let's see. We don't actually need to store this average. We could just put this in here. So we could do this. Might save us a little bit. What else can we do? We could make this a deck instead of a list. That might help. What else can we do? We might be able to avoid this. I don't know if that will help or not. Let's just see if this saves us anything. A little bit. So we went from a 5% up to a 26%. So that's pretty good. All right. I mean, it's still not good, but it's a good improvement. Let's see, what else could we do? We could try to get rid of this. Now, because we have this base case, this might still work. Saves us a conditional, but it does mean more recursive calls. So yeah, it doesn't really save us anything. 26 and 26. So it didn't save us anything at all. All right. What else could we do here? All right, we could try making this a deck. Let's do that. I don't know if this will really save us anything, but sometimes it does. So we'll make this a deck. And that means instead of pop 0, we have to do a pop left. All right, this is my last try. And that actually doesn't help at all. It takes us down to a 16%. So that really doesn't help us. Let's jump in here and see what other people are doing. Jump up to the top. All right. Whoa, what is this? Yeah, I don't know what this is. Looks like they're using some dictionary to store the values, which is it's interesting. I mean, clearly it's doing something smart, but I'm gonna move on to something else. Let's see what else we got here. This looks very similar. Yeah, this looks very similar. I wonder why this one's so much faster. I guess it's a more compact version of our code. Interesting. Oh, so this is smart. So this is what they're doing. We have two separate loops. We've got our while loop that's popping out our elements or our nodes, and then we have our second sort of recursive loop when we calculate the average for our subtrees. Now in here, they're doing kind of both at the same time. They're calculating the averages, and then they're adding it to the result while keeping this result externally. So this result is more of a global result. So that's pretty smart. They're actually just adding these as they go. That's probably the right way to do this. All right, well, I don't have a ton of time, so that is it for me. For this one, we broke it down into two subproblems. The first subproblem is just traversing our tree. The second subproblem is finding the average, and that includes finding the total and finding the count of nodes. All right, so that is it for me. I hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.